So good morning everyone. I am Jomar Salazar Salmon, a third year BS Accounting Information System student, and today I will be discussing the chapter 18, 19, and also chapter 20. So let's start with chapter 18, which has the content of the physical design process. So in this chapter, we will use the logical model of the data warehouse to develop and complete the physical model. Physical design gets the work of the project team closer to implementation and deployment. Every task so far has both the project and the grand logical model. Now, physical design moves it to the next significant phases. So the data warehouse physical design has 7 steps. So let's start with the first step, which is the develop standards. So standards take on greater importance in the data warehouse environment. This is because the use of the object names is not confined to the IT department. Users will also be referring to the objects by names when they formulate and run their own queries. As standards are quite significant, we'll come back to them a little later in this chapter. Now let's move on to the next steps of the physical design. So the next step is create aggregates plan. So let us say that in your environment more than 80% of the queries ask for summary information. So if your data warehouse stores data only at the lowest level of granularity, every such query has to read through all the detailed records and sum them up. It is possible that many of the aggregates will be present in the OLAP system. So if OLAP instances are not universal used by all users, then the necessary aggregates must be present in the main warehouse. So the third step is determine the data partitioning scheme. So you must consider partitioning options for each fact table. So should some be partitioned vertically and others horizontally? So you may find that some of your dimension tables are also candidates for partitioning. So product dimension tables are especially large. Examine each of your dimension tables and determine which of these must be partitioned. So let's move on with the next step, which is the establish clustering options. So in the data warehouse, many of the data access patterns rely on sequential access of large quantities of data. So you need to establish the proper clustering options before completing the physical model. So examine the tables, so it will be the table by table, and find pairs that are related. So this means that rows from the related tables are usually accessed together for processing in many cases. So the next step is prepare an indexing strategy. So this is a crucial step in the physical design. So unlike OLTP system, the data warehouse is query-centric. As you know, indexing is perhaps the most effective mechanism for improving performance. The plan must indicate the indexes for each table. So each table presents the sequence in which the indexes will be created. Describe the indexes that are expected to be built in the very first instance of the database. So next is the assigned storage structures. So in a data warehouse, you are not just concerned with the physical files for the data warehouse tables. So your storage assignment plan must include other types of storage, such as the temporary data extract files, the staging area, and also any storage needed for front-end application. So the last and final step is to complete the physical model. So this final step reviews and confirms the completion of the prior activities and tasks. So by the time you reach this step, you have the standards for naming the database objects. You have determined which aggregates tables are necessary and how you're going to partition the large tables. So you have completed the indexing strategy and also have planned for other performance options. You also know where to put the physical files. So all the information from the prior steps enables you to complete the physical model. So the result is the creation of the physical scheme. So you can code the data definition language statements in the chosen RDBMS and create the physical structure in the data dictionary. So next we'll be discussing the optimizing physical storage, the indexing purpose and process, and also the performance enhancement techniques. So first is the optimizing physical storage. So consider the processing of a query. So after the query is verified for syntax and checked against the data dictionary for authorization, the DBMS translates the query statement to determine which data is requested. So from data entries about the tables, rows and columns desired, the DBMS maps the request to the physical storage where the data access take place. So you have basically two choices for storing data of these two-dimension tables. So store records from each table in one physical file, or if the records from these tables are retrieved together most of the time. So then store records from both the tables in a single physical file. So in either case, records are stored in a file. So next we'll be discussing the indexing purpose and process. So in a query-centric system like the data warehouse environment, the need to process queries faster dominates. So there is no sure way of turning your users away from the data warehouse than by unreasonably slow queries. So let us consider the technique of indexing from the perspective of the data warehouse. So the data tables are read-only. So this feature implies that you almost never update the records or delete records, and records are not inserted into the tables after the loads. So next we'll be discussing the performance enhancement techniques. So apart from the indexing techniques that we have discussed in the previous section, so a few other methods also improve performance in a data warehouse. So for example, physically compacting the data when writing to storage enables more data to be loaded into a single block. So that also means that more data may be retrieved in one grid. So another method for improving performance is the merging of tables. So again, this method enables more data to be retrieved in one grid. So if you purge unwanted and unnecessary data from the warehouse in a regular manner, so many techniques are available through the DBMS. So and most of these techniques are especially suitable for the data warehouse environment. So now let's move on to the chapter 19, which is the content of data warehouse deployment. So data warehouse deployment is the next phase after construction. So in the deployment phase, you attend the last few details, turn the data warehouse on, and let the users reap the benefits. So by the time you reach the deployment phase, the majority of the functions are completed. So the main concerns in the deployment phase relate to the users getting the training, support, and the hardware and tools they need to get into the warehouse. So let us inspect each major activity in the deployment phase. So as you move along, pick up tips and adapt them to your environment. So we have the complete user acceptance, which is the first major data activity in the data warehouse. So proper acceptance of the system by the users is not just a formality in the deployment phase. It is an absolute necessity. So do not proceed to force the deployment before the key user representative express their satisfaction about the data warehouse. So next is the perform initial loads. So we reviewed how initial loads are done and covered methods for incremental loads. We also covered the 4 different modes for applying data to the warehouse repository. So by the time the project arrives at the deployment phase, the team must have tested sample initial loads and mock incremental loads. So next is the get users desktop ready. So getting the user machines ready for the data warehouse is a comparatively small part in terms of the overall effort from beginning to end. So although the effort may be much less than 10% of the total activities, what the users see and experience at their desktops is what counts for them. Then the complete initial user training. So the importance of training and orientation for the users cannot be overemphasized. IT professionals may think of the separate components of data, applications, and tools. From an IT department's point of view, training is thought of as training about these 3 components. But to the users, it is all one. They do not distinguish between applications and tools. So next is the Institute Initial User Support. So in the early days of post-deployment, every member of the data warehouse support staff is usually very busy. So note the basic support centers. So the user representative in each department is the first point of contact. This person must have been trained well enough to answer most of the questions on the applications and data content. So now we will have the last major data warehouse deployment activity, which is the deploy in stages. So building and deploying a data warehouse is a major undertaking for any organization. This is a project that calls for many different types of skills. So the data warehouse encompasses several different technologies. Dimensional modeling is a very different approach not previously used by designers in any operational systems. So the process of data extraction, transformation, and loading is tedious and intensive. So users receive information in vastly new ways. So now we will move on to the data warehouse security and also the backup and recovery that is part of the chapter 19. So first, we will be discussing the data warehouse security. So a data warehouse is a veritable gold mine of information. So all of the organization's critical information is readily available in a format that is easy to retrieve and use. In a single operational system, security provisions govern a smaller segment of the corporate data, but data warehouse security extends to a very large portion of the enterprise data. So in addition, the security provisions must cover all the information that is extracted from the data warehouse and stored in other data areas such as the OLAP system. So next is the backup and recovery. So in an OLTP mission critical system, loss of data and downtime cannot be tolerated. So loss of data can produce serious consequences. So in a system such as airlines, reservations, or online order taking, downtime even for a short duration can cause losses in the millions of dollars. So why back up the data warehouse? So a data warehouse houses huge amounts of data that is taken years to gather and accumulate. So the historical data may go back 10 or even up to 20 years. Before the data arrives at the data warehouse, you know that it has gone through an elaborate process of cleansing and transformation. Now we will have the chapter 20, which is the last chapter that we will be discussing today. So the chapter 20 talks about the growth and maintenance. So this is just the beginning. More data marts and more deployment versions have to follow. So the team needs to ensure that it is well poised for growth. You need to make sure that the monitoring functions are all in place to constantly keep the team informed of the status. So the training and support functions must be consolidated and streamlined. The team must confirm that all of the administrative functions are ready and working. So database tuning must continue at a regular pace. So now we'll be discussing the monitoring the data warehouse and managing the data warehouse. So when you implement an OLTP system, you do not stop with the deployment. The database administrator continues to inspect system performance. The project team continues to monitor how the new system matches up with the requirements and deliver the results. Monitoring the data warehouse is comparable to what happens in an OLTP system, except for one big difference. So the results of the monitoring give you the data needed to plan for growth and to improve performance. So after the deployment of the initial version of the data warehouse, the management function switches gear. Now, at this point, data warehouse management is concerned with two principal functions. The first is maintenance management. The data warehouse administrative team must keep all the functions going in the best possible manner. The second is change management. As new versions of the warehouse are deployed, as new releases of the tools become available, as improvements and automation take place in the ETL functions, the administrative team's focus includes enhancements and also revisions. That's all for this discussion. I hope you gather some information that will be used in the near future. So have a good day and thank you.